Dear viewers, welcome back to the TCE LearnEasy series program. In this example, we will see how to apply the vertical loads as well the lateral load, namely seismic load in a space frame or space structure, RCC space frame. So this is the plan of the building in which we are going to apply the said loads. So initially we need to create the geometry of this plan by giving the nodal coordinates. So initially we need to form the location of the columns, get the coordinates, and then we need to enter into the geometry section of StaadPro. So we have created this model using the geometry, that is a nodes option, nodes and coordinates option. So node 1 coordinate 0, 0, 0 and node 2 line. So by giving the coordinates, this coordinates at the footing level will be formed, and then using the translation option we can form the other nodes as well, the other beams of the ground plus 1 story construction. So we have the model developed. Now let us see as well the member properties and as well the support conditions have been given. Now we will see how to give the loads. So in which we will be giving seismic load also. So to give the loads, we will go to loading. Let us define, give load definitions. So click definitions, then click reference load definitions, click add. So let the first load be dead load. So dead this be dead load, type it as dead load, add. Second load be live load. So live load you will classify into two, that is you will have floor live load, and then we will have another live load will be roof live load. So in case of seismic loading we need to do like this, roof live, click add. So here we have dead load, floor live, roof live. So close this, let us take dead load, click add. In dead load we need to add the self weight, say -1, add, and then as we have given all the self weight of the slab, the weathering post load in the previous example under the dead load category, here also we will include. So let us have the floor load option. So floor load, self weight of the slabs will be 25 into 0.15, which will be -3.75 kilonewton per meter square, and the Y range will be, so this starts here, say this is 1.5, this is 4.2, so the Y range will be 5.7 to 9.3. So the Y range will be 5.7 to 9.3. That is, we are adding the self weight of this floor slab as well the roof slab. Therefore, we are giving this. Click add. Then let us add the floor load as -1.5. That is floor finish in case of floor slab. So -1.5. So here the Y range will be ground floor roof slab. So this will be 5.7, 5.7. Click add. And the weathering post load, let the weathering post load be 3.2. So it acts at the level of the roof, so which is 9.3. Click add, and then we need to move to the floor live load and roof live load. Before that, let us add the wall loads also in the member load option. So let the parapet wall load be -6 kilonewton per meter, add. Let the wall load over the floor beams be minus 25 kilonewton per meter, add, and let the wall load above the plinth beam be minus 30 kilonewton per meter, add, close. So this self-height need to be assigned to the members. Similarly, the UDL, this wall load need to be assigned to the members. So that we'll be doing. And in case of floor live, go to floor live, click add. So floor live will be -2. So give the floor load will be -2, and the Y range will be, say it is floor slab. So floor slab acts at 5.7 meter to 5.7. So click add. So this will apply the floor load. Then the roof live load. Click roof live. Click add. Say let it be the floor load be minus 1.5 kilonewton per meter square. Click add. Click close. Now we need to give all these loads. All the loads to the members. So first let us select self-height. Select self-height. Select all the entire structure. Click assign to selected beams. Click assign. Click yes. Now these loads need to be assigned. So let us have the front view, or let us have the cut section and apply the wall loads. That would be better. So let us cut at the level of 43. So that will be available in utilities, in structure tools, cut section. So we need to make a cut section at the XZ plane at the level of say 43. Click OK. Then it will be cut at this level. So take this -6, which is need to be applied over the periphery of the parapet. So the parapet wall will be acting on the periphery alone. So this load of 6 kilonewton. These loads need to be calculated earlier before assigning. So assign to the selected beams. Click assign. Click yes. Then view whole structure. So now this -25 need to be applied at this level of 29. So again, go to utilities, go to structure tools, make a cut section, XZ plane. Now at the node number 29, cut at the node number 29. Should be cut here. Take this load and have the plan in hand and apply the wall loads. Wherever wall comes, you need to add. So outer periphery there will be definitely walls. So and inner, wherever walls are available, we need to apply. Say for example, we have wall here, we don't have wall here. So we have, if we have wall here, similarly if you have wall here, then if you have wall here. So add only the wall wherever you have the walls. Then click assign, click yes. Now go to view, display whole structure. The loading. You see the okay. So then we need to cut at the plinth beam level. So go to utilities, go to cut section, structure tools, cut section, XZ plane at the node 15. So at node 15, please make a cut, then click OK. You are going to use this wall load over the plinth beams. So let all the exterior walls be added, and interior walls, as per the plan, wherever we have walls, we need to add. So let us have wall here, say this wall here, this wall here, wall here, and this is wall. Otherwise, if you don't have wall, you can leave. then click assign to select beams, click assign, click yes. Then view whole structure. So now all these loads have been applied. Then now we need to go to the seismic definition. So click loading, click load and definition, in expand definition, load and definitions. So, and in which we have seismic definitions. So click seismic definitions, click add, in which we have IS, say select the code as IS 1893, IS 1893-2016. Then click generate. So you need to select the city, let the city be selected as Madurai, where we are going to model this. So HICL Madurai, simply type M, you will get Madurai. Then the factors, RC building with special, choose RC building with special moment resistant frames. So let us choose this option, and these factors will come as such. And then residential or commercial buildings, choose residential or commercial buildings. And then select the rock type as hard soil. Then RC MRF, let it be as such. 1.5 will be, let it be as such. And the foundation depth will be 1.5 meter. It is typed as 5 meters. So foundation depth will give us 1.5. Click generate, click add. So this will come over here. Then close this, select this, then click add, click add. Now here we need to use the reference load option. So click reference load, and select the R1, that is dead load. Select R1 and bring it over here. The factor for R1 will be 1, and select R2, that is floor live load, bring it here, and the factor will be 0.25. This is because as per IS 1893-2016, for calculating the design seismic forces of the structure, the imposed load on roof need not be considered. 100% of dead load and 25% or 50% of floor live load alone are need to be considered. That's why we have taken the reference load R1 and multiply by 1 and R2 multiply by 0.25. Click add, click close. So these are the things which we need to do in case of seismic definitions. Now we need to add to the load cases. So go to load case details, click add. So first load will be, say let it be seismic. So seismic acting in the, say we will call it as EQ plus X, add. Then seismic EQ minus X, add. Then EQ, that is earthquake load, EQ plus Z, add. Then fourth case, EQ minus Z, add. Then fifth category will be simply dead load. So let it be dead load, add. And sixth category will be live load, add as live load. Click add, click close. So click earthquake plus, click add, type the factor as, choose the seismic loads x direction and factor as 1, click add, click close. Then go to equi minus x, click add, choose seismic loads, then x direction -1, negative x direction, so -1, click add, click close. Similarly for z, click equi z, click add, click seismic loads, click z direction, now z direction, click +1, add, close. Then equi minus z, click add, seismic loads, z direction, -1, click add. So we need to add all these loads, equi plus x, earthquake minus x, earthquake plus z and earthquake minus z. Then we need to add the dead load and live load. So for dead load, click dead load, click add. Now we need to repeat the load since we have already added. So click repeat load, select reference load, then click R1 dead load, click add or bring it to this side, click add, click close. Then go to live load, click add, go to live load, again repeat load, reference load. Now we need to add R2 as well, R3 here. So press Ctrl and select these two, bring this side, click add, click close. So all these things will be added here in the reference case. Then to create the load combination, click the load case details, click add, click auto load combination, select the code as IS426 bar IS800, click generate loads. So all these type of 34 load combinations will be generated, click add, click close. So this load combination will be available here. So this is the way we need to define the seismic definition. We need to give the reference loads and then give the seismic definition and add the repeat and reference loads like in this manner and give the load combination. We'll be getting this. So this completes loading and analysis. As we ever do, we can do the analysis as go to analysis commands, perform analysis, print all, add, close. Then select everything, go to design, select concrete, select the code IS426, select the parameters, bring all the parameters this side. So you'll be having FC, press Ctrl, FY main, FY secondary, maximum main, maximum secondary, then minimum main, minimum secondary, bring this side, click OK, define parameters, say let the grade of concrete be 20,000 kilonewton per meter square, click assign, FY main, let us use 500,000, assign, FY secondary, let us use 415 grade steel, 415,000, assign, then maximum main, let 25 mm rods be used, click assign, maximum secondary 12, assign, minimum main 12, assign, minimum secondary 8, assign, close. Then commands. So before going to the command, select only the beams. So go to select option, say beams parallel to X and beams parallel to Z. Go to commands, design beam, assign, close. Select the columns by clicking beams parallel to y-axis. Go to commands, design, columns, assign, close. Then select everything by pressing Ctrl A, go to commands, take off, assign, close. So this completes the pre-processing, and then processing will be, we need to go to analysis and design, click run analysis, click save. So this is how one need to give the vertical loads as well the lateral load or seismic loads, and then do the analysis and design. So after design we can just click and we can see the results. What will be there? Say 320 will be required at the top and 360 is required at the bottom. So due to seismic loading, the reinforcement will be somewhat higher. So here there is no concrete design. That means the column has failed. So we need to redesign this column. How about this? Let us see. So this column has failed. Let us see some intermediate column. So this column also failed. So the columns are not sufficient to take up this load. So we need to change the column dimensions, or whichever members fail, we need to change the dimensions. So dear viewers, thank you all for watching this video on creation of the space frame, giving the loads, that is the vertical loads as well the seismic loads, and then analyzing and designing. Please subscribe and help many to reach many.